rocks, nothing else, just a soil, just dropped onto the boundary. We can also pick that out here, and in the Kilkee we can see the same things outside the valleys. We see well-drained soils superimposed on green scrub.
And those intervals where you see rooted stuff too.
Rooted. They're totally atypical for Carboniferous. They're totally well-drained, they're leached. They're not the swampy conditions that you see in your typical delta plain. They're covered with charcoal on the top surfaces. They've got desiccation cracks filled of clean quartz sand on the top surfaces. So they're exposed, dry, like forest fires, and they're just superimposed. I mean, they're completely pasted green. So that would be, as the term there is indicated, that's another really prime evidence that these big sand bodies are valleys.
So you're getting almost a 90-degree change in the valley organism?
It's about a 45 to 50-degree change from this here to here. Interestingly though, all these mouth bars are rotated towards the east. So it's the valley system alone which switches direction.
Okay, so there's no change in coastline.
Well, these systems are prograding east. This is going up to the northeast. Yeah. These are all going out to the east. So the Tollig is the one oddball in here. It's big. So we've got a 60-kilometre dip section here. It's getting muddier down dip. We've got a 20-kilometre strike section in this one.
You see similar observations in the Kilkee in terms of the fill, like more bypass, more aggregation.
All the erosion surfaces are closely spaced at the bottom, and then they space as you come up.
That's really, I mean, it's classic low stand. It's like, you know, it's just that evidence of a perforating and then aggregating system, which is further dip with more bypass and then aggregation. Let's get the Exxon. Yeah, this is great.
So Trevor does this, huh?
Trevor typically goes through this bit, but basically I think if we look at it here, the Tollig Point slump would be below it. This would be the sort of distally seen sequence boundary. And you know, in the literature you hear a lot about this sequence boundary here, this part of the sector. You know, bases of incised valleys. A lot published on that. A lot published on this surface down here, below the base of 4 fab. I tend to call a surface of convenience, because actually all the sediments up here are equivalent to the erosion surface up dip. You know, it's not really the same. There's not really a line through there with nothing happening all the way along it. So that's the sequence boundary down it. You hear a lot less about this sector here between the two. But we think these downward shifts here in the shelf margin is what we're seeing. We're signaling it in that sector right there. So this would be Tollig Point here. This would be the Tollig Sandstone up in here, and it would feed out, the Tollig Sandstone would feed out into its own shelf margin wedge down dip.
I think that stacking pattern, like in that more shelfal position, it's like low stand progradation versus high stand progradation. Low stand progradation, prograde then aggrade, versus high stand progradation, aggrade then prograde. It's all like where the space is being created, following it. And so you're seeing that stacking pattern, even evidence of it in the incised valley fill. And the fact that more erosion bypass, more aggregation, preservation over time, more low stand type of more space being created up dip. Kind of thing.
Everything's stepping back.
Yeah, everything's back stepping.
But even as the space window stepping back, the river system is still efficiently filling it with sand.
Yeah.
So it's astonishing. Given the amount of silt that's in the delta front,
it's a lot of silt.
There must be an awful lot of sand coming through this system.
Because just think about the amount of time represented by that lower portion of the fill versus the upper portion of the fill.
That would be a considerable time.
That's a lot of sand in your rise trucking by.
So you look at the Ross, and the Ross is a 65% sand system, 80% in places, and it's the same petrography as this. It's not a big leap of faith to say that's where it was dumped. There would have been, at this time in the Tollig, further out the basin, a Ross age dump of sand.
What did inboard of the shoreline look like at this time? I mean, relief for the drainage area for the fluvial systems?
We got no evidence beyond the limits of the basin, but within the Clare basin, I'd imagine it would have been featureless and flat out to where the property line is now. Beyond the property line, I mean, where the nearest hills were, I just don't know. And I would say here to the property line basin. Grain size of the sand, intriguing. Very fine to find the only concentration of lower medium grain sand is in beds in the bottom of the valley. So in the bottom of the valley, near the basal erosion surface, you'll pick up some beds of lowest medium grain sand. Now they're probably beds, first beds of fine grain sand, but they seem to be concentrated in beds. And then the only other place you see medium grain sand concentrated is in the bottom of the Ross, in the oldest part of the Ross, which we interpret as the distal part of the system. In the biggest beds in the Ross, the bigger beds out to the edge of the fan. They have medium grade sand in them. When I was doing my thin section work